Got to give the people. Give it, give it. Give the people what they want. All right, Mr. Bass, I'm back. This one I think is gonna be quick. Let's get it. 3.2, E and the natural log. So here's just some stuff you gotta remember. So remember, log base 10 undoes the base of 10 because they're inverse functions, right? So if you have 10 to the x, you undo that with a log base 10. So for example, right, 10 to the x, if I want to do it, I can just go, oh, just do log 10 of that. We undo it, and I'm left with x, okay? So if I have log base 8, that undoes any exponent that's attached to a base of 8. Because again, logs and bases are inverse functions, okay? So now what we're going to add to this is e, which is a number. It's the base of approximately 2.718, which we covered in a previous video, right? So e to the x is about 2.718 to the x, because e is about 2.718. Well, what if I want to undo the base of e? E has a special function that it's inverse, right? We wouldn't take the log of e, but what we take is called the natural log, and that's actually ln. So the natural log undoes specifically base e. The base of ln, oh, there goes my voice. The base of ln is e, but you don't have to write it. The natural log equations work exactly like log equations. So here's what I mean. If I have, example, the ln of 1 equals x, that means, basically it's saying the natural log of base e to the first equals x, right? So we know that e is my base, x is my exponent, just like in logs, and 1 is the solution. So e to what power equals 1? Well, we know x has to equal 0. This is just like we did with log equations, all right? So ln to the x 5, so the natural log of x equals 5 means that we're saying oops, let me undo that. That means my base, so it's, stop. Okay, so it's really saying, right, the natural log base e to the x equals 5. You don't have to rewrite it, but just recognize that the natural log always has a base of e. So it's saying my base is e, and my exponent is 5. So e to the 5th power equals x. That's what that means. I don't know why I wrote e like that, because I'm rushing. But it's okay. We got this. Boom. So that's that piece. Okay? And that's hopefully super straightforward. Now we have natural log properties. And natural log properties, the basic natural log properties work exactly the same as the basic log properties. So, just like we did before, example 1, the natural log of 1 equals 0 because, well, why is that true? If I write this as an exponential, my base is e, my exponent is 0, and any number to the 0 power has to equal 1, just like we did with the log ones. So the next one says the natural log of e equals 1 because what? So really I need to rewrite this so I get an idea of how it looks. I'm really saying here the natural log of e to the e equals 1. So if I write it like that, my base is e, my exponent is 1, e to the 1st power is e, just like we knew. Then I have my last couple. The third one says the natural log of e to the x equals x. and the natural log of e to the natural log of x equals x. This also mimics what we did before. So let me rewrite this one. ln e to the e x equals x. Well, if I wrote that, I know that the natural log of e and e cancel out. So I'm only left with x. And if I have this one, e to the natural log of x, again, e and the natural log of e cancel out, so I'm only left with x. Right? They are inverses. E and natural log are inverses. E and the natural log are inverses. They cancel each other out. Finally, part 4 says, if natural log of x is equal to the natural log of y, then x has to equal y, which makes perfect sense, right? ln x equals ln y. Well, the natural logs, or if these both parts are the same, then that means these both parts must be the same. So x and y have to be equal to each other, because it only makes sense. And again, these are the exact same properties that we just had with logs 2 days ago. That's it. It's me. Easy work, not too much. See you all tomorrow.